Now today's our topic is application of junction diode as a rectifier. See, rectifier means AC source to DC source. So conversion of AC source to DC source, that device is called a rectifier. Here we have two types of rectifier, half wave rectifier and full wave rectifier. First is half wave and the another way one is full wave. Okay, so I am drawing the circuit of half wave rectifier. This is our primary coil, this is our secondary coil. So this is like transformer, and further it is connected with one PN junction diode. Further we have one resistance. So this is our output here. So output, and this is our input, right? So because of this transformer in half wave rectifier, by input we are giving wave pattern like full wave, means positive negative, right? Now this wave is given by input this primary coil. Now exactly what happens whenever this signal comes to here, and because of this diode, in first interval this will be in positive, this is in negative. So in first interval, positive connected with P type of semiconductor and negative connected with N type. So that means this is forward bias, and whenever diode is in forward bias, then it can flow, it can pass that current. So we are getting some signal for the first half, so that is our output. Now exactly what happens, now for second time interval, now because of this negative wave pattern, now this positive becomes negative and this negative becomes positive. Now negative to P type semiconductor, negative to positive type terminal. So that means here this is now in reverse bias. We know that reverse bias we don't get too much current, means current will be neglected. So here we don't get any current. So in second half we don't get anything. Now again third quarter, now positive means now this becomes positive, this becomes negative. Again forward bias, we are getting signal as output. So here we are getting that. Again it will change, now comes to reverse bias, and reverse bias we don't get any current, so here stops. So in half wave rectifier we are getting half waves, only half waves we are getting. So that half wave is only in one direction and it is in positive direction, right? So that is half wave rectifier. Now we come to full wave rectifier. The circuit of full wave rectifier, again same, primary coil, similar transformer, secondary coil, right? Now this again further connect with one diode, and this further connect with the another diode. Further that, okay, so this whole arrangement is further connect with one resistance, and from here it is further connect with one here. So this is our output and this is our input, right? So that is output and that is input. Now here full wave, so always two diodes we have to connect to get full wave, right? Similarly this is our input as a full positive negative, okay? Now output that we have to draw. Now what happens exactly, for first initial this is positive, okay? So for that this is positive, this is negative. So for that, if I am giving the name this diode D1 and this diode D2, now negative positive connect with P type, negative connect with here N type, right? But here negative connect with P type and negative connect with positive type. So this is in reverse bias, this is in forward bias. Because of forward bias of this diode, we are getting some signal as an output, so we are getting positive, right? Now interval changes, so because of that this polarity becomes negative and this becomes positive. Now this negative with positive means this is in reverse bias, but positive connects with positive here, negative connects with negative here. Now that means this is in forward bias, and because of that we get output as a positive. So we can here D1, this is called D1 input. So what is D2 input? D2 input is exactly opposite to that, means first starts from negative, then positive, from negative, then positive. So this is the waveform of diode D2 input. So see here one as a positive, here was second as a positive, right? Similar now for third means this is positive, this is negative. So because of D1 is in forward bias, this is reverse bias, we don't get current through this, we get current through this. That's why again we are getting some waveform. So again we are getting waveform due to D2. So this continues on, this goes on further. So that's why we are getting continuous current in only one direction. That's why we call it as full wave rectifier. So this is the working of half wave and full wave rectifier. Now we have one filter circuit. It's, for example, we have used that rectifier full wave. Now still this rectifier, after we are getting output, still we have some projections of alternating current. So we have to filter it, we have to remove that projections of alternating current. So that's why further we have to connect with capacitor, and further we have to connect with some resistance. So overall as an output now we are getting now total complete 100% DC signal. So this circuit is known as filter circuit. Filter circuit, to convert somehow, rectifier just sends some AC signals inside DC signals, means there will be 80% DC signal but 20% of AC signal, so that we have to remove, and now it will be 100% DC signal as an output. So that's our application of junction as a diode as a rectifier. Thank you very much.